Okay, in this video I'm going to show you how to solve for angles using the sine rule. And first of all, we're going to have to remember what the sine rule is. Here it is in relation to sides or angles. So this was my previous video, and we're going to be using this formula right here. And we're also going to be using my highly mathematical term of to solve for the unknown, we're going to cross multiply and divide by that lone ranger. We're just going to have one more step in this because we're finding an angle. So let's look at our first example here, and we see that it will in fact be the sine rule because I have that angle and side opposite thing. And now I set up my proportion and I'm using this formula right here. That's it. So I can say, alright, 8 over sine 75 equals 6 over sine theta. Okay, now here, I'm solving for theta, so this is going to be my unknown. Cross multiply here, and divide by that lone ranger. So I'm going to say sine theta equals 6 times sine 75 divided by 8. Now I don't have the theta yet, I don't have the angle yet. So I'm just going to say sine theta. I'm going to work all of this out on the calculator, and I'm not going to round it. Okay, so let's do that. Okay, and I just didn't round it. I can leave it on the calculator. So to solve for an angle in trigonometry, we do the opposite of sine, which is inverse sine. Sine -1, if that's what you want to call it. You either input this value again, or on your calculator you can use the this answer button there to rewrite that number. But don't round here yet. Do not round. Okay, we inverse sine that, and we'll get our angle. I'll round it to no decimal places, 46 degrees. Two significant figures. Okay, so that's cool. Let's look at another example here. Okay, in this example I want to solve for this angle x here. First of all, do I have the sine rule going on? I've got the angle and side opposite, so yes I do. Okay, let's say 15 over sine of angle x equals what? 18 over sine of 125. And again, I'm using my sine rule formula. Remember, I only need 2 out of these 3 to make a proportion. Okay, cross multiply and divide by the lone ranger. What does that look like? It's going to look like sine of angle x equals 15 times sine 125 divided by that 18. Okay, and I get a value for this on the calculator. I'll work that out. Okay, I get this decimal. I don't do any rounding. And to find the angle x, I'm going to use inverse sine of this value here, 0.682626, and you just leave that value on your calculator, and you'll get 43 degrees rounded to no decimal places, to 2 significant figures. Okay, so yeah, it doesn't matter where that sine x is. So that sine of that angle, it can be anywhere. As long as you do this cross multiply and divide by the lone guy, you'll be good. There's one more thing about the sine rule, and I'll go over it right now. Okay, my last example, it's called the ambiguous case. I hope I spelled that right. And that's when what is that? Okay, it occurs when the shorter of the 2 given sides, 10, is opposite the given angle. All right, so 10 is the shorter of the 2 given sides, and it's opposite the given angle, 41. And what's going to happen is you can get 2 possible values of r. Well, why? Okay, well, first of all, because I can draw. There can be another triangle that has an angle of 41 degrees in these 2 sides, and I'm not gonna draw it perfectly, but I could have another side of that triangle looking like this, where that is also, this side right here, 10 centimeters, creating an isosceles triangle. Okay, so R could also be this angle of this triangle. I can get two different values of r. Alright, so to get this guy, let's just call this, I guess, r dash or something. Just, you could give it another variable. But what's that going to be? R dash will be, I'm not going to do the whole proof right now. It's a fairly simple proof. It will be the supplement, make sure I spell that one right, to r. And supplement means they add to 180 degrees. Add to 180 degrees. So we'll just figure out this first one, like we normally do with the sine rule. And then this one is just going to be whatever adds to 180 of this one, the supplement. If this is 60, this would be 120. Okay, so let's set up our proportion. It looks a bit more complicated now. Sorry about that. We've got angle, side opposite, angle, side opposite. Now my diagram's looking really confusing. That's okay. So I've got 11 over sine r, and I'm saying this r, equals 10 over sine 41. Okay, now I'm going to do my cross multiply and divide thing. Okay, 11 times sine 41 divided by 10. I get a decimal approximation for this. And I get something like this. I'm not rounding. And finally, I do the inverse sine of this value here. And I'll get 46 degrees, another 40-something degree angle. Let's just chance that all of these have been 40-something to two significant figures. Okay, well, isn't that great? Okay, so that means that angle right there would be 46 degrees. But I could also have this triangle with the supplement of r dash, and that's just going to be 180 minus 46, which would give me 134 degrees. It's supplement. Okay, so that's called the ambiguous case, which you do have to look out for. This answer is not wrong. It just this problem kind of has two different answers that could arise. Okay, that's it. So just look out for that one called the ambiguous case, and good luck.